All right, today we're going to talk about solving quadratic equations, and you're on the next test on a week tomorrow. You have to demonstrate the three methods to solve a quadratic equation, okay? So we're going to talk about all three. You've done quadratic formula, you've done solving by factoring. I don't think you've done solving by completing the square. Okay. A quadratic equation should be in this form where you have the quadratic term or the x squared term, you have the linear term or the x term, and you have the constant term. It is placed in order of decreasing degree. And the degree is the of any term is the sum of the exponents. So place in order of decreasing degree. So notice the degree of this is 2. The degree of the exponent on x is 1, so the degree of that is 1. There's no x variable here, so the degree on 2 is 0. See, so it's 2, 1, 0. It's in order of decreasing degree. But you should have your quadratic term before your linear term, before your constant term. When we are solving quadratic equations, when it says solve a quadratic equations, basically what they're asking you to do is find the x-intercepts, right? Here are the x-intercepts are where it crosses the x-axis. So you have three possibilities. You have two distinct, that should be a 2 there. You have two distinct real roots. Another word for distinct is different. So in other words, you have two roots. In this case, it's hard to read, and I can't read it, but I assume it's maybe -1, -5, something like that, right? Wherever they cross the x-axis is your root. Now, this is the case of two equal roots. They do this for consistency because you have two distinct real roots, two equal roots, or two complex roots, or in other words, 0 real solutions or 0 real roots. You could go like this, 0 real roots. So here, the root is x equals 2. So they just say there's two equal roots. They're just being consistent. Here you have 0 real roots because notice the graph does not cross the x-axis. So there's 0 roots. The graph does not cross the x-axis. So you have three different situations. Let's do some you're going to learn three methods. We're going to talk about three methods. Finding roots of a quadratic equation is equivalent to finding the x-intercepts. That's important, right? So first of all, we're going to start out with solving by completing the square. When we solve by completing the square, these are the steps right here. Divide the entire equation by the coefficient of the quadratic term. Take the constant term to the right-hand side. Have and square the coefficient of the linear term. Add it to both sides. Simplify. Factor the perfect square. Take the square root. Isolate the variable and simplify. So notice this is similar to but different from, right? Because you completed the square before. Different from, very different. It's a little bit different, not very different, but it's different from changing a function from standard form to vertex form. This is different. On the very first day of this unit, we learned how to change a function from standard form and write it to vertex form because you could pick off the vertex. Here we're solving by completing the square. There's some steps that are similar, but it's different. please be aware that they're different because students confuse these two things. They get these two things mixed up. This we complete the square in one way and we treat it one way. This we complete the square in one way and we treat it a little bit differently. They're similar but different, and because they're similar, students get a little confused. Okay, solve the following quadratic equations by completing the square. Notice we divide the entire equation by the coefficient of the quadratic term. There's our quadratic term, and the coefficient is 1. If we divide everything by 1, nothing changes, so we just leave it. So now we take the constant term to the right-hand side. So a squared minus 8a equals 2. Have and square the coefficient of the linear term. So when we do that, when we have and square, you go 1/2 times negative 8 and square it, we get negative 4 squared, we get 16. So notice we add 16, right? Notice we add it to both sides. We add it on one side and we add it on the other side. That's how it's different. We don't add it and subtract it. We add it to one side, we add it to the other side, right? Don't get mixed up with this method. Okay, so now we have a perfect square trinomial, so that's easy to factor. Square root of the first term is a, square root of the last term is 4. That's a minus, all squared equals 18. So now we can take the square, we factored it, we take the square root of both sides. A minus 4 equals plus or minus root 18. A equals 4 plus or minus root 18. What do you think? Are we done? What should we do? Take the perfect square out of the square root sign, right? So a equals 4 plus, I'm just going to factor it. We have, it's 9 times 2. We can take the square root of 9. So a equals 4 plus or minus 3 root 2. Good? Can I explain anything better? We're okay? Always simplify the radical. Yes. Well, whenever you're solving, you're not really putting it in vertex form. That's a whole different question that we did on day 1. That you write it in vertex form when they tell you to write it in vertex form. When they say solve, they'll tell you solve by completing the square, or solve by factoring, or solve using the quadratic. Okay, in this case, we have to divide by a. So let's do it. Divide by a, make my day. I'm going to teach you my raps so you remember the steps. Divide by a, right? So 2/3 divided by 2/3 is p squared. Let's do our rough work off to the side. 4, I'll do it over here. 4 divided by 2/3 is equal to 4 times 3 over 2, and that's going to be 12, which is 6. So it's going to be, I forgot my 2/3, right? No. We're dividing by 2/3, so it disappeared. So this is going to be plus 6p. Now we have to divide 3 by 2/3. And I'm just doing so when you divide by a fraction, you have to multiply by the reciprocal, and that's 9 over 2. But I'll make it right over here, okay? Okay, so right now I divided by a. So now I'm going to move that guy over, divide by A, make my day. Kick that sucker to the other side. P squared plus 6p. It's better when you sing it fast. You can't do rap slow. It's got to be fast, you know. Huh? I'll show you the steps, and then when we're done this, I'll show you the step. I'll rap it fast, okay? Okay. Having and squaring is the play. So we divide by 2 and we square it. So what we're going to do is we're going to go 1/2 times 6 squared equals 3 squared equals 9. So we're going to, but now instead of adding it and subtracting it like we did up here in the Unit 1 lesson, we're going to add it to both sides. What you do to the left side of the equation, you do to the right side to make sure this equality holds, right? You have to be careful with that equal sign. Okay, now we have a perfect square trinomial, so it's easy to factor. And we have to get a common denominator to add these together. That's 9 is equivalent to 18 over 2. So p plus 3 all squared equals 9 over 2. Take the square root of both sides. P plus 3 equals plus or minus 3 over root 2. Multiply by root 2 over root 2 because you need to rationalize the denominator. Okay, maybe I did that too soon. Is this confusing you? You don't like that just yet? We can do it later. So we'll move this guy to the other side. Okay, so, but we need to rationalize this denominator, like always rationalize your denominator. Always, always, always. So we rationalize this guy, multiply by root 2 over root 2. This is going to be negative 3 plus or minus 3 root 2 over 2. And you could take it a step further, because this would be negative 6 over 2 plus or minus 3 over root 2 over 2. And that would be negative 6 plus or minus 3 root 2 over 2. Now I would accept this answer and I would accept this answer. Here you're just putting it over, you're just bringing everything together, which is okay too. Good? Okay. Okay, ready for my rap? I'll stand up. I got to get in the groove. Okay. It's all the steps here. Divide by A, make my day. Kick that sucker to the other side. Having and squaring is the play. Add it to the left, add it to the right. First factorize it, then you rooterize it. Kick that sucker with all your might. That's the game, make my day. That's the game, make my day. Thank you. Thank you. Those, believe it or not, are the steps. I made that up like 20 years ago. 20 years ago when I couldn't sleep one night because I had to come up with a trick to help students remember, and somehow that came into my head. Okay, let's do solving by factoring. What? I guess so. No, I wasn't. I wasn't, because rap was out even then. Man, there's some crazy rappers out there, eh? They're so fast. Okay, solve by factoring. Do you want me to review factoring by decomposition, or should we jump right into the factoring? What would you like? Huh? Jump right in? Okay. So somehow we have to get 5m squared. So the only way you can do that is 5m times m, right? And somehow we have to get a positive 2. But a negative times a negative is a positive 2. So why don't we go minus 2, minus 1. How's that? Let's see how that works. Okay, check. On a test, just check. This one? Well, you have to get a positive 2, right? The only way you can get that is if you go minus 2 times minus 1 to get a positive 2. So I either put minus 2 minus 1 here and see if it works, or I put minus 1 and minus 2 there to see if it works. Let's check. 5m times m is 5m squared, minus 5m minus 2m is minus 7m, plus 2. Right? Sometimes it's a little harder. Like if this was a 6, you could go 1 times 6 or 2 times 3. It's a little harder. But with 2, you only need a 1 and a 2. It has to be negative, add up to be negative. So you know these two are negative. And you know that's a negative times a negative is a positive. If you can, absolutely. Whatever gets you the right answer. Okay, so 5m minus 2 equals 0, or m minus 1 equals 0. 5m equals 2, or m equals 2 over 5. M equals 1. There's our two answers. So this is a case of two distinct real roots. Or two different, that's the classification, right? It's not asking for the nature of the roots. I'm just reviewing the material I just talked about. Okay, how are we going to do this one? What's our first step? Sorry? Yeah, what we really want to do is get rid of the denominator. Get rid of get rid of denominators. Get rid of denominators to solve. Again, here, get rid of denominator. First step. So, what you do is you multiply by the lowest common denominator, which in this case is p minus 3 times p plus 1 times this big guy, 2 over p minus 3 minus 4 over p plus 1 plus 3 equals, equals 0 times what you do to one side, you have to do to the other. Okay? So right away we get rid of it. We're just wiping it out of the equation. So when I multiply this times this, p minus 3 divides out. So I have 2 times p plus 1 minus, here p plus 1 divides out, so I'm left with p minus 3 plus 3 times p minus 3 p plus 1, and 0 times anything is 0. We're running out of space here, but that's okay. We'll figure out something. I might just have to, you guys, I might have to erase this just for now, because we're going to need that space for the answer. But you know that here you should get rid of the denominator also. So 2p plus 2. I hope you can see that okay. Maybe I'm going to just zoom in. It's going to go blurry a little bit, but it'll clear up. Okay, minus 4p plus 12 plus 3 times, I'm going to FOIL here, p squared plus minus 2p minus 3 equals 0. So we're going to have to multiply that out, but this is minus 2p plus 14, right? I just collected like terms here, plus 3p squared minus 6p plus, oh, that should be minus 9 equals 0. Collect like terms, right? It's just the number crunching. 3p squared minus 8p. 14 minus 9 is plus 5. Okay, so I'm going to factor again, just jump right into it. If you need a review of factoring by decomposition, I can do that with you one-on-one. To get a 3, there's only one way. It's 3p times 1p. To get a 5, well, that's a negative, so it looks like we're going to have two negatives here. Looks like this will be negative 5, negative 1, right? Because that gets me positive. Let's just check. 3p squared minus 3p minus 5p. Yeah, it's working. It's the correct factorization. So 3p minus 5 equals 0, p minus 1 equals 0, p equals 5 over 3, p equals 1. Those are our two answers. End the story. Okay, I'm going to let you guys do this one. Just the hint is at 4m squared minus 10m equals 0. You just factor that. The answers are m equals 0 or m equals 5 over 2. But let's do this one. What should I multiply both sides by to get rid of the denominator? Yeah, so 12 times 1/3 x squared minus 1/4 x. Always remember what you do to the one side, you have to do to the other. So this is going to be 4x squared minus 3x equals 0. All we can factor out is an x. X times 4x minus 3 equals 0. X equals 0, or 4x minus 3 equals 0. 4x equals 3. X equals 3 over 4. There's one answer, and there's another answer. Okay, 3 goes into 12 4 times, so it's 4x squared. 4 goes into 12 3 times, so it's 3x equals 0. Or, you know, 1/3 of 12 is 4, 1/4 of 12 is 3. Yes? Oh, because I know I have to get a positive 5. So I can get a 5 by going plus 5 or plus 1. Oh, but I'm seeing this is negative. So I know we have to get negative. So if this is negative, I know these have to be negative. Well, You do, because you're trying to get the negative 8p. Like, you're always checking yourself to make sure you, not only are you getting the 5, but you're also checking to make sure you get, yeah, yeah. Yeah, because somehow I have to get a negative 3p and a negative 5p to add up to negative 8. So I know these must be negative. If they were positive, I'd be getting positive 8, and that doesn't fit this.
Okay, I was wondering how you could do that in the last chapter too, because we would always go with that separate.
That's sort of the way I do. It's trial and error in my head. It's experience. But if you need the method of decomposition, then by all means use it. Okay. Okay, derivation of the quadratic formula. I'm going to use my math wrap, okay? If you have, it's really, I'm just following these steps, right? To derive it. I have to derive it for you. The equation is this, right? And we're going to use this equation to find the quadratic formula. So you divide by a, right? And what we're going to do, well, a divided by a, that's going to be x squared plus bx over a, and you have to move that guy to the other side. My end result will be the quadratic formula. Do you remember this? Yeah, but I have to derive it for you. We have to somehow go from this to this. That's what I'm doing. Remember that formula? Okay, so you haven't squared the coefficient of the middle term. So we're going to go 1/2 times b over a squared equals b squared over 4a squared. So we have to add it to each side. That's my completing the square, right? Divide by a, make my day. Kick that sucker to the other side. Having and squaring is the play, right? So we add b squared over 4a squared. Add it to the left, add it to the right. Because what you do to one side of an equation, you have to do to the other. And I think there's an extra mark here. I don't want to confuse it. We'll just get rid of it. Okay, now we have a perfect square trinomial. So it's square root of the first term, square root of the last term. That's a positive. Here we're going to need a common denominator. So I'm going to multiply this guy by 4a over 4a. Do you see how our common denominator is 4a squared? So I need to multiply this guy by 4a. So this is negative 4ac plus b squared. Or b squared minus 4ac. Right? I had to go negative c over a times 4a over 4a. That equals negative 4ac over 4a squared. Okay, then you take the square root equals plus or minus root. I'm just changing the order. And the square root of that is 2a. So x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. And that gives us our quadratic. I have a common denominator. I can bring them together. Can I explain anything better? Yes. I needed to derive it for you. In all honesty, I've been teaching for 28 years. I've never, I've maybe seen this as a TI question once. Sorry? Sure. You're welcome. It's kind of a big lesson, isn't it? And you know, sorry? Yep, the whole thing. See how negative b is over 2a? This is over 2a, so bringing it together, it's all over 2a. Don't forget your study notes are due on Friday, okay? Okay, solve by using the quadratic formula. When we solve, we have to set one side to 0. So we'll move this guy over. 4m squared I didn't know I had a clip. That helps. Because it was getting stuck on my sweater. Okay, so x equals, oh no, it's an m. Oh, so we'll change it to m. M equals negative b plus or minus b squared minus 4ac all over 2a. So m, our negative b, well, b is negative 6, but negative 6 is positive 6, plus or minus negative 6 squared minus 4 times 4 times 1, all over 2 times 4. So m equals, right, number crunching. Just go do your number crunching on a test slowly, gently. 36 minus 16 over 8. M equals 6 plus or minus root 20 over 8. Are we done? We have to simplify our radical. So m equals 6 plus or minus square root of 4 times 5 over 8. M equals 6 plus or minus 2 root 5 over 8. Are we done? Okay, we have to reduce. M equals 2 times 3 plus or minus root 5. I'm factoring, and then 2 goes into 2 once, 2 goes into 8 4 times. So my answer is m equals 3 plus or minus root 5 over 4. We'll do one more example. Like that. You're good? This headset ruins my beautiful hair. Okay, ready? Recall that the discriminant b squared minus 4ac determines the nature of roots. Did you talk about nature of roots last year? The discriminant, b squared. So, when b squared minus 4ac is greater than 0, you have two different roots, right? It's actually written right here, right? If b squared minus 4ac, there's two different roots. If it equals 0, there's two equal roots. If it's less than 0, there's no real roots. You're going to learn about complex numbers next year. It's when you have a negative value in a square root sign, how do you handle that? But x, so let's do it, okay? Make sure you set one side to 0. So if they say use the discriminant, don't go solving. They don't want you to do that. We calculate b squared minus 4ac equals 3 squared minus 4 times 1 times 2. 9 minus 8 equals 1. Oh, greater than 0. When the discriminant, see how the discriminant is greater than 0, so we have two answers, a plus and a minus answer up here. Same here. So you're going to have two distinct real roots. My bad. Let's subtract 6x. X squared minus 6x plus 9 equals 0. We're determining I'm just doing one of each example. So here, b squared minus 4ac equals negative 6 squared minus 4 times 1 times 9. Notice here we have 36 minus 36 equals 0. So we have two equal real roots. No, just try to be consistent. Always use 2. 2, 2, 2. As strange as it seems. b squared minus 4ac equals negative 3 squared minus 4 times 1 times 11. We have 9 minus 40. Sorry. That equals negative 35, less than 0, no real roots. Or 2, if you want to say, or you can say 2 complex roots. I'm going to do one problem-solving question with you. There's too many examples. You can give them a try tonight. The sum of the squares of 3 consecutive integers is 245. Find the numbers. Okay, they're consecutive. They just mean one right after each other, like 2, 3, 4, 5, 6, 7, 10, 11, 12, whatever. So let the integers be x, x plus 1, x plus 2. Now the sum of their squares is 245. So you know x squared plus x plus 1 squared plus x plus 2 squared equals 245, right? The sum of their squares is 245. So let's FOIL, collect like terms, and we'll decide how to solve. X squared, this FOILed is x squared plus 2x plus 1 plus x squared plus 4x plus 4 minus 245 equals 0. So we have 3x squared plus 6x minus 240 equals 0. What's one thing I can do to make my life a whole lot easier? You can divide everything by 3, right? You don't want to work with trying to solve 6 squared minus 4 times 3 times negative 240. So divide, if you can do everything to one side, do the same thing to both sides, do it. We'll divide by 3, make our life easier. How do you think we're going to do that? Well, this is negative. To get a negative number, we need a positive and a negative. One way to get 80 is 8 times 10. So why don't we make 10 the positive one and 8 the negative one? So x equals negative 10 or x equals 8. Ooh, looks like we can get 2 sets of answers. 2 sets of answers will satisfy this problem. So one answer is if x is 8, the numbers are going to be 8. 8 plus 1 is 9. 8 plus 2 is 10. If the answer is negative 10, sorry, I'm just trying to show you up here, then it could be negative 10 plus 1 is negative 9. Negative 9 plus 1 is negative 8. Lots of problem solving for you today. Maybe we'll do 1 or 2. Huh? Sure. How far up? Is that okay? Is that high enough? You're good? My pleasure. Does anyone need the bottom part of that? Can I explain anything better?